Okay, so this is the standard covalent bonding and compounds question. So first question here, we've got hydrogen chloride. We've got an image of hydrogen covalently bonded and an image of chlorine covalently bonded. You can see here hydrogen is H2 because there's 2 hydrogen atoms, and chlorine is Cl2 because there's 2 chlorine atoms. Okay, this is what you call a diatomic molecule, which just means di means 2 atoms together to make that molecule. So that's how hydrogen and chlorine exist as an element. Okay. Question is, can you draw a similar diagram to represent a molecule of hydrogen chloride? It tells you that it's 1 hydrogen and 1 chlorine. You only need to show the outer energy levels. So first thing you need to do is 2 overlapping circles. In the centre of one you've got a hydrogen and the other one chlorine. So hydrogen only has 1 electron in the outer shell, so we're going to put that in the overlap where it's going to share with chlorine. Chlorine is in group 7, so I know that it's got 7 electrons on the outer shell. And this is the link between group number and number of electrons on the outer shell. So we'll do chlorine's electrons as circles just so we can see the difference between the 2 atoms. So there's 2, 4, 6, so I'm going to put the 7th one in the overlap. So that is it for hydrogen chloride. So further down, they're wanting a balanced symbol equation for the reaction above. So hydrogen, tells us in the question, is denoted as H2. So I'm going to write H2 first. Plus chlorine, which again tells us there is Cl2. And this is going to give us hydrogen chloride. And the question here shows you the symbol for hydrogen chloride. For that, you would get 1 mark. This isn't balanced though, and the question asks for it to be balanced. So on this side I've got 2 hydrogens, whereas on this side I've only got 1. This side I've got 2 chlorines, whereas on this side I've only got 1. So I'm having to put a big 2 in front of the HCl, so therefore now that reaction is balanced. Okay. Over to the other side, we've got an image of hydrogen chloride now, where you can see the electrons. First question, they want to know what do these crosses, or sometimes dots, represent. So those are the electrons. Remember, in covalent bonding, they're always shared. What type of chemical bonds hold the atoms in this molecule together? Well, we've just said that. I can see there's an overlap of electrons being shared there, so I then know that that is a type of covalent bonding. It's not ionic. Ionic is transferring electrons. Okay, slightly harder question then. Would you expect hydrogen chloride to be a gas, a liquid or a solid at room temperature and pressure? Explain your answer. So first of all, we should know that room temperature is usually about 20 degrees-ish. Okay? You guys have used hydrogen chloride at school, and you should also know that this can be found in the labs. And in the labs it's usually a liquid. Okay, and pressure is normal pressure in the room. And explain your answer. So first thing we need to say is, would you expect it to be a gas, a liquid or a solid? And the mark scheme is accepting a gas or a liquid. So the first thing you want to say is hydrogen chloride is a gas, a liquid at room temperature and pressure. Now I want to say why. So this is because, I'll just put HCl is a small molecule with weak intermolecular bonds or forces. Because it's got these weak bonds, this means these bonds can break easily at a low temperature and pressure such as 20 degrees. So at 20 degrees those bonds will have broken, therefore it's going to exist as a gas or a liquid. On the flip side, if this was high, if it said what would you expect hydrogen chloride to be at 200 degrees, well at 200 degrees it's very, very hot, so it will have broken those bonds as well. So again, that would be a gas, most likely. Okay. Last question then, and this is a 4 marker. So, millions of years ago, the Earth formed a giant ball of molten rock. The outer surface cooled, forming a thin, solid outer crust. Volcanic activity on the surface produced an atmosphere containing the compounds carbon dioxide, ammonia, methane and water vapour. The question is, describe the bonding in any one of these compounds, and you must talk about electronic structures. So any one of these compounds, they're talking about carbon dioxide, ammonia, methane or water. So the first thing I'd be tempted to do, before I choose which one I talk about, is do I know the formula of any of these? Carbon dioxide, we should all know, and water, we should all know. So if you don't know ammonia or methane, that's fine, because we're only looking at one of these compounds. Just for reference, methane is CH4 and ammonia is NH3. Okay, you then got to pick one of these and talk and describe about the bonding. So I'm going to go with carbon dioxide. But I'm going to answer for carbon dioxide, but the structure of my answer would work for any of these 4. Okay, so first thing I'm going to say is carbon dioxide contains 1 carbon atom and 2 oxygen atoms, which are bonded covalently. And know it's covalent bonding because they're both non-metals. So now we're going to talk about what it looks like. So it's always helpful to have this drawn out as well, and you'll get points for drawings. So carbon dioxide, if I do my drawing at the side here, you've got carbon in the centre. Okay, and you've got 2 oxygens either side. Carbon I know is in group 4, so it's going to have 4 electrons, and then it's going to be in the overlap. Oxygen is in group 6, so it's going to share 2 of its electrons there. It's going to have 4 left over. I'm doing dots and crosses so you can see where the different electrons have come from. So in covalent bonding, we need to say what happens in terms of the electrons that are being shared. So you want to say carbon shares 2 electrons with each oxygen atom. This is a double covalent bond. The atoms share electrons to achieve a full outer shell. Okay, and the last point I'm going to make is about the strength of the bond. This is a strong covalent bond which requires lots of energy to break. Okay, so I might have picked a tricky one there, but that is carbon dioxide. Just for your reference on the other side now, I'm just going to draw what the other 3 structures look like. So H2O, you would want to be describing the bond in your H2O, so you've got your O in the centre, your H's overlapping at the side. Hydrogen's got 1 electron, and that pairs up with 1 from oxygen. Oxygen's in group 6, so it's got 4 left. Okay, so that's H2O. Ammonia, which is NH3, you've got your nitrogen in the centre, you've got 3 hydrogens overlapping, again, hydrogen has 1 electron. Nitrogen's in group 5, so the first thing we'll do is pair these off. That's 3, 2 more left for group 5. They like to be in pairs like that. And the last one, methane. Carbon in the centre, 4 hydrogens around the outside, each with 1 electron. The carbon in group 4 just has enough to pair off those 4 hydrogens. Okay, so these are single covalent bonds because it's just one pair, whereas that's why I'm saying I picked the tricky one, because these are 2 pairs of electrons being shared, so those are double covalent bonds.